Have you ever found yourself in a situation when you start to work with a new tool or technology and just started from total experimentation, using simplest approach or maybe sometimes even taking shortcuts? And then after some time, what usually happens in tech is that something what was meant to be a temporary solution becomes a permanent one, which is fine. But my question is, what would happen if, after some time, you were asked to redeploy similar project once again, or maybe to add a new environment there, or maybe add a new service? I'm curious if it would be easy for you to use your existing resources just by changing some piece of configuration if the code was designed in a smart way, or maybe you will end up detangling spaghetti and actually came up to the conclusion that now with that knowledge you have today, it would be just easier to design it from scratch. So the topic of my today's presentation is how to develop scalable infrastructure as a code with Terraform Cloud workspaces. So how to plan for all that covers for the future. After that short pitch, let me introduce myself. My name is Agata Skorupka, and I am cloud consultant in the Scale Factory. So I work in the DevOps field for a couple of years, but I come from developer and data scientist background. On the side, I am still doing some research in data science and AI. In the field of graphs, I recently have written my thesis, waiting for PhD defense, which means I'm looking forward to using my freed up time by attending to more conferences and contributing to open source. In my free time, I do pole dance. So what does it really mean to make your ISC scalable? There is a famous quotation, failing to plan means often planning to fail, which actually uses Terraform terminology in a very funny but truthful way. So what I'm trying to say here that often in the process of experimentation or getting acquainted with the new tool, we don't think about end goal because it's difficult. But what actually is required here to maintain this approach is playing with a vision of end. Just knowing from the beginning what you want to achieve and how you want to achieve for your future decisions. And obviously it's difficult, but that is why I hope this talk will be useful. There are at least two scalable two dimensions where your ISC is possible to be scaled, and one is spinning up a new environment. Second is adding a new service. What does it really mean here is that you just need to deploy a new set of resources by using what you already have. And what does it really mean is that you want to reuse as much of your code base as possible. So it would be great if that would be easy to reconfigure. And for that purpose, you probably already know what is Terraform modules, and they are perfect for it. But the question is, what if with other dependencies? So for example, how to map your resources, especially in the context of environments, to your cloud accounts, assuming you're using cloud provider, of course. Why do you need to do that? So basically, you want to separate your environments usually as much as possible, just for the sake of security and reducing your blast radius. Of course, I don't want to jinx it, but blast radius is scope of your resources being affected in the case of compromising. For example, some malicious behavior, or maybe your developers just being adventurous. So that is one thing. At the same time, you need to also plan how do you want map your resources to your directory structure, which can sound really simple, but believe me, I have seen many configurations which were very difficult to entangle or even to understand what's going on there and what are the dependencies between resources and environments. But if I was about to give one advice, it would be whatever you choose, just stay consistent to your convention. I think what introduces the often, not always, but often the biggest amount of mess is just having many conventions and using them at the same time. Why is also directory topic that important? It is because um, a directory when you execute of Terraform execution is actually a unit of your state file as well. So basically, the more directories with Terraform executions you have, the more state files. And why do you need that? So here again, you want to separate your state as much as possible. Maybe not as much possible, but if it's feasible and if it makes sense logically, then go for it. And why? One, because it's again reducing blast radius. So scope of your resources bundled together. But second reason is actually very prosaic, and it will actually speed up your feedback loops. What does it mean? Having an enormous Terraform state with each and every resource there often means your Terraform execution taking forever just because of refreshing Terraform state. And that is something you may not notice from the beginning because obviously at the beginning you don't have that much resources. But yeah, something to plan for in the future as well. Another thing, how do you actually want to manage your environments? Is maybe calling models enough for you? Maybe after some time you will find out, okay, this solution is not scaling that much. So what are other options? One would be using Terraform workspaces, especially if you want to use the same code base, because Terraform workspace is a tool you can use via CLI just to create multiple configurations for the same directory, but it will have multiple state files, so something to account for. If it's the only one code base, one directory, it may, we already know, it may not be so easy to manage according to scalability in the future. So what are other options? Another thing which I quite often encounter, especially in the past, not that much nowadays, is using TerraGround as a tool of environment management. And to be honest, I'm not very big fan of that solution, just because it is introducing another layer of abstraction, and it is significantly slowing down your feedback loops here. The third option, which is actually recommended by me and will be shown in this presentation, is using your Terraform Cloud workspaces. And I find it best to explain what it is and how does it work just by showing it to you. And just one caveat, Terraform Cloud Workspaces is something totally different than Terraform Workspace. Last but not least, delivery. How do you want to deploy your code? So do you want to execute it locally? Do you want to store your state remotely? Maybe you want to use CI/CD. These all are very important questions, which actually may go back to you when you will already have lots of resources then. At the beginning, you maybe don't really see the need for CI/CD, but what if you are growing? So about CI/CD, we will talk at the next part of the presentation, but now let me show you some code snippets. How can you structure your code? And one solution would be on the surface the simplest one, just defining some resources, just as in documentation. And this solution may appear readable, but in fact it is not that much, because here I don't see one place where I can see what can be subject to change in that configuration. So here the question would be, okay, let's imagine I want to spin the same thing up in another environment. This is, as you can see, I'm using AWS provider S3 bucket, really simple example. But let's imagine we want to create another environment for that. So what do I do now? Okay, I might create another directory for it. But if I want to use the same code, I will probably copy and paste it or change variable. But let's right now talk about this approach. So copying and pasting. But this kind of solution would make it very difficult to track changes between configurations. And you obviously want that, because if you want to test your code before production, your environment needs to be as close as possible to your target one. So you need to find a way to track those changes. So what is the more repeatable solution? It is the Terraform modules. Something you probably already know. But the question I encounter very common is, how actually do I store my modules? How do I call them? And there are several options to it. First is just use source by referencing to the same repository. But that means you're storing your all modules probably in the same. It is often called monorepository. Maybe even your actual infrastructure as a code is there. So it is very difficult to track changes again, right? Because even if you don't have the teamwork, but imagine if you do, then one person changes one piece of the main branch, which is referred to here. Another person changes another module, and the situation becomes really difficult. Of course, it may happen even if you're working on your own with it. So basically, you can use versions here. That is the solution to that problem. But versions are managed by tag releases on your repository. You can also use branches, but imagine referencing the same repository in multiple ways. And also you can have only one tag for all modules. So even if you don't see it in the beginning, it will get complicated very quickly. I have seen solutions like that after some time, and maybe they are not that difficult to entangle, but that can be actual pain. What is the solution to entangle? Is just create a separate repository for each and every module. You can version it in that way, reference, as in second example of this snippet, to specific version, maybe to specific branch. But what I also want to add here is that if you can save your time but not writing a module, do that. And you may ask, okay, but what do you mean? Weren't we talking about advantage of modules above defining just simple resources? And the question will be answered, yes, but you can still use modules without writing them. That is the point of modules. And there are some great provider modules, as in the case of AWS, so 4 snippet of code, and maybe they will be a good fit for your solution. And of course, it may happen. You need more customizations, you need more features, so write your own. But in my opinion, in most cases, provider modules may be enough for standard use cases. If you want to actually manage and maintain your own module, it is a good solution to actually connect it to your Terraform Cloud. You still need to have it in your repository. So you may ask, okay, but what is the advantage here? And my response would be, what is actually difficult in that architecture that you have only resources, you really don't see what is subject to change. If you have model, you can see it from an example of calling the module. or from the documentation. But you usually need to write a documentation. And Terraform Cloud generates it for you in an automatic way. So what can we see here is that all inputs listed with specific types. We have outputs here, dependencies, all resources created by the module, as well as usage instructions, all created automatically for you. I think it is pretty convenient to use Terraform Cloud to manage your modules. Two things to bear in mind is that you need to use specific versioning conventions as well as naming conventions to be able to connect to your module in version control system. Another topic we already mentioned is deployments. How do you want to manage them? So one thing you need to decide, and this is actually not a difficult decision, but something I will mention, is how do you want to store your state? Do you want to store it locally, so on the laptop of the person who is actually executing Terraform, or remotely? So first solution obviously makes teamwork almost impossible, and also in that solution state is dependent on that person and on that laptop, and it has no backup, so it's okay for experimentation but not for other things. So definitely consider remote state. You can use encryption just to keep it secure, and also other options like locking state with some DynamoDB table, and so on and so forth. But other topic, a little on the side of the state, is how do you want to execute Terraform? Locally, you can do that even if your state is remote, or remotely as well. What does local execution means? It means that each developer, so here the collaboration is possible, as you can see, just executes Terraform plan and other Terraform commands just from his laptop, from his console. And other solution, remote, would be just execution via CI/CD, for example. And you may ask, okay, but why do we need that? So you may not notice it at the beginning, but after some time, you will need to see how your configurations changed, who is actually the author of specific version of changes, who deployed, who destroyed the database without any warning on your production environment. You basically need logs. Okay, for your successful and unsuccessful deployments, you need logs to track changes and even to store your plans, not only like be ephemeral plans disappearing on some laptop. But where is also CI/CD convenient is that you can configure some automatic triggers. For example, running plan always on the PR to the repository, and let's imagine apply on a merge, which I think is really cool. And here is one example of how can we configure that. That example is written in GitHub Actions. It is also showing us how to be able to account for several environments. This is just a simple example, just a proposition, just environment from branch name. But you may think, okay, but that is another thing to deploy and to manage. Maybe there is another solution. And my answer would be yes, that is exactly where Terraform Cloud comes in handy. And before I will show you Terraform Cloud, I want you to see what actually I have here. What is the directory structure I propose? So I suggest to focus on the file directory on the left-hand side. And let's ignore Cloud directory for a moment. So as you can see, I have one module. It is in the other directory, in fact, other repository. and my infrastructure in also separate one. Again, separation of concerns. Each environment is in different directory, but it also has specific subdirectories. And each subdirectory is actually designed to handle another service within the specific environment. And the idea here is to store this dev in the one account. But maybe your services, of course, I have one service here for now. This is just simple as free bucket. But maybe your services, and that is also the question to ask you at the beginning, because it can change actually your directory structure. Do you want some resources to be shared across services? For example, subnets, virtual private cloud just in AWS, and you may actually see how much the module configuration differs from defining configurations just from resources. Here it is very clear for me what do I need to change and what are my variables. Actually, variables are here, but yes, generally this is far more readable than what I have on the right hand side and easier to track changes. And that is actually the purpose of IAC. It should be self-documented. Both are actually, but I prefer left-hand side kind of documentation. Okay, so we have it. And now let me jump and show you how does it actually correspond to Terraform Cloud. Each subdirectory has its own workspace, meaning it will have separate series of Terraform runs. And let me see what is my example service state. This is a typo actually, not intentional mistake, of course. Let's go to version control. What do I want to show you is it is configured to run plan automatically. Apply I need to approve, but what is a cool thing is that the runs are executed only if something in this directory changes. So not only it saves me runs, but also it makes my life easier. And this is really cool. For example, if I go to common, this will only trigger anything if anything in this directory changes. And then we see, okay, fine, but do I need to configure this all from the scratch? And my answer would be that is exactly where a cloud directory comes in handy. So what is going on here? I'm using Terraform Cloud Provider, and I am using a cool module developed by my colleagues from the Scale Factory to connect to my Terraform Workspace organization and my version control hosting system organization, which is also under the name Agata Demo. I authenticate there using a specific token for VCS integration with Terraform Cloud generated from the Terraform Cloud console. And I use this specific repository, which is actually corresponding to infra directory here, okay? But what is the purpose of that? It is because under variables, I can define in an easy way what workspace, Terraform Cloud workspace do I want to provide, and what directory should the execution correspond. So let me demonstrate that for you. I just uncommented production resources, and I push it to main. What will happen now is that after some time, okay, now I see this is planning immediately after push. And here I have the decision to apply because a plan is created automatically, but apply on approval, which is, I think, the good practice. So what will actually happen? Let's wait a moment for it. Is that oh, I need to see all workspaces, is that I have 2 new workspaces created. They are error, but don't worry about it. We will fix that in a second. Under settings, I can see that it will be only triggered whenever this directory changes. And it is cool because I didn't configure it manually. Okay, so now let's go back to our code. And actually, I didn't show you, but the error we got there is probably about the credentials that Terraform Cloud does not have permissions, and indeed it doesn't, because we need to find a way to okay, we need to find a way, okay, it's not making my life easier, to authenticate to AWS, and preferably a secure way. So as you can see, we are defining variable var sets here, and the cool thing is that it actually allows for populating some variables inside the chosen Terraform Cloud workspaces. That means that this variable will be plugged to each and every of these workspaces, and it will have value like this. So a cool feature. But what is going on here is, I don't know if you're familiar with OIDC integration. That is what I'm using here. Very secure way to integrate your Terraform, for example, with cloud provider, because it does not use any secrets, any access keys, or anything. We just need to set up something in the account, and then yeah, so on the AWS side it is just 2 clicks, but later on the Terraform side we just need to set up one variable for our workspace, and then resources will be deployed there, which I think is cool. So let's see this in practice, and as you may see, it is actually how I map my environments and resources to accounts. So I have this separation of concerns. Both prod have different account, and dev is also different. And notice that if I want to have another account, like even for shared resources, I can also share between accounts. I can also add it here. So okay. And let's see if that works. I really hope so. Because that is the demo. However, it often happens with the demo that it maybe won't work. Okay, first, my cloud workspace is planning. I need to apply it. So basically, yes, that is what I wanted to achieve. This applies good. And as you can see, managing new environments and even services is very easy. You just add your directory here, you just add a specific role, and then whenever you will push, it is only within one repository, but whenever if you push to specific directory, your changes will be planned. If you want, they can also be applied automatically, right? So, okay, what is going on here? I don't see that error is gone, because please notice I didn't change anything within this directory. I only am able to execute plans automatically if I change something in this directory. So maybe I can actually show you. This plan is running because I triggered it from UI. So let's just do something here. I mean, nothing is in common really, but let's do that. Let's change file in this directory. Okay. And let's see what is going on here. Yes, my plan is there. And what is actually going on here is that I am creating a S3 packet website, which I can actually show you. This will be development one. Let's see if it works. And if my production will work, then I think I need to add prod here. So let us see. Yes, and as you can see, this is also applying. Prod common is plan and finish because nothing was there to change, but as you can see, it was actually triggered by the automatic execution. So basically, I noticed I'm running out of time, which is fine. Just let me go back to my slides. I have one more for you. Yeah. So what are my last words from this presentation? Is just whatever you will decide, I suggest you be consistent with it. I think the most spaghetti comes from using multiple conventions and sticking to them. Another thing is that actively use versioning because that is one way to just keep everything in desired state and in order and under control, not your resources subject to change whenever there is a new commit, for example. For the purpose of security, you want to separate your concerns. It's not only about security. I really believe it will help detangle your architecture and plan for scalable solution. What I would suggest is also deploy remotely to be able to track plans and executions. You don't have to use Terraform Cloud. You can write your own CI/CD. It is totally fine, but it really helps, especially if your infrastructure grows. So that is all from my side today. Thank you for your attention, and I hope you found this presentation useful.